Hey everybody, welcome back. One of the highlights of the 2016 Microhams convention this year was a presentation by Casey Halverson and Morgan Redfield about a Kickstarter project they successfully launched. They call it HamShield. Imagine, if you will, an amateur radio transceiver that plugs in to an Arduino. You can completely control it with software you write yourselves. Their project is an example of how the maker movement and amateur radio are merging together more and more. Casey has been a ham radio operator for many years. Morgan was inspired by this project to get his amateur radio license as well. Raspberry Pi, BeagleBone Black, and even Arduinos are now starting to have shields and hats and capes that enable radio, amateur radio. Even Adafruit now has radio shields available, and all of these things require amateur radio licenses. So it's only natural that makers spend a week or so studying and take a test to get their amateur radio license. It's all about a hobby they already know and enjoy. It's probably the best $15 they'll ever spend. I think you'll enjoy the presentation done by these two enthusiastic and creative Kickstarters. And if you're one of the backers of this project, I think you'll particularly enjoy the question and answer period that comes at the end. Join me now as we enter Building 37 on the Microsoft campus in Redmond, Washington.
Next session here we have two speakers, Casey Halverson, KC7IBT, and Morgan Redfield, KG7OGM. They are part of the HamShield, or they are the HamShield Kickstarter amateur radio project. The HamShield is a successfully funded Kickstarter project that allows an Arduino to control an FM transceiver. In this talk, they're going to discuss about how they designed and kickstarted the HamShield and the lessons they learned in the process. So please welcome Casey and Morgan.
So before we actually get started, I want to talk a little bit about the HamShield and kind of how I see that fitting in with the rest of this conference and what we've already heard. At the first presentation today, we heard a little bit about Ham Radio 2.0, Ham Radio 1.0, the transition between those two. And really, one of the reasons that I'm so excited about the HamShield is because I kind of see it as an intermediate step, maybe Ham Radio 1.5 or something, where it still uses analog modes, but it allows people to control the radio from an Arduino or from their computer through an Arduino. So it really kind of serves as a transition step to get from just like a standard handy-talkie to something that you can actually control from your smartphone. And to tell you a little bit about myself, I actually just got my ham license last year and really came into this through the maker movement more than anything else. I was really excited about robotics and about electronics, and when Casey first got me involved in the HamShield, that was really kind of what I was most interested in. But then as I learned more about ham radio in general, I decided, I don't just want to work on the electronics for this. I want to get my ham license and actually make some contacts and do some more interesting stuff with ham radio in general. So that's a little bit about me. I'm going to turn it over to Casey here, and he can tell you about himself and the HamShield.
Hi, I'm Casey Halverson, KC7IBT, and I've been an amateur radio operator since I was about 14. Got my ham license, my Tech Plus, and I used a VHF handy-talkie, but I always dreamed of a way to create a more dynamic radio where we could control it via software to create new ideas and new inventions. And that bug is, it's been in my head for quite a few years, and finally with the Arduino, I realized that it could be possible. So we took a off-the-shelf component, all-in-one radio IC, and we made something really cool with it, and I hope you guys like it. So, so
we're going to go over exactly why we built the HamShield and kind of why we made some design decisions that we did. We'll talk a little bit about the design and testing of the HamShield as we were first getting started with the hardware, and then we'll go over the Kickstarter what the process of kickstarting a radio project is like, and some lessons that we've learned from that, and we definitely learned a lot of lessons from that process. And then we'll talk about the stretch goals, some RF issues that cropped up, and manufacturing and user support. And we're hoping to leave a lot of time for questions. I know we've got some backers in the audience, so feel free to ask us whatever you want, or heckle us, or whatever you want. But we'll save that to the end.
So, why did we make HamShield? You know, we wanted a handy talkie that we could automate. There's a lot of handy talkies out there. Some people have made up little connectors into the audio jack, and they're able to send and receive audio, maybe key on the transmitter. But we really wanted something that allowed us to change the frequency, you know, do sub-audio tones, you know, create maybe a new amateur radio mode using FM, maybe combine packet radio with another technology. So we were looking to build a fully configurable handy talkie that also enabled, you know, Bluetooth connections as well. We wanted this to be a little box that maybe you interacted with your phone. I mean, it was a sort of a, you know, up in the sky idea. Well, we could make this really cool thing. Maybe even, you know, tack Android onto it or just something like that. But we got a bit ahead of ourselves. But that was the original motivation for the HamShield. And so we started investigating different radio technologies, different radio ICs out there. There's a lot of really low-cost, off-the-shelf radio ICs that power a lot of the handy talkies today. I'm sure most of you are familiar with those. And then also there's some stuff in the SDR field as well. So we took a look at all the different technologies. But we cracked open a Baofeng radio actually, and we found there's a neat little chip inside. So we decided to see what we could do. You know, originally we were going to hack into the radio and pull the I2C lines off, and well, that wasn't the right way to do it. So we just decided to build something very basic to experiment with it, and that was a Arduino Shield. And I'm sure most of you know what Arduino is, but if not, they're little microcontroller boards. You can buy this thing off Amazon for $10, and you can write in C++ and control, you know, different functions of the Arduino. And if you don't know how to program, that's fine too. There's a million examples out there that you can just plug in and maybe tweak a few values and learn from there. So. We made an Arduino Shield because you know, it's easy to program, it's easy to repurpose, it's used in all kinds of different prototyping, and so this is one of our early prototype Arduino Shields here, but a shield is essentially a little board with a header on it that docks onto the Arduino, and you can stack them. And you know, to enable the Bluetooth connectivity, you could probably even use a second Bluetooth Arduino Shield, or you can maybe connect, you know, maybe an audio shield to maybe, you know, play back some recordings for repeater ID or something like that. So you can definitely add on different things to the Arduino and change the functionality of this radio.
All right. So basically, we came up with this idea that we wanted to really enable a lot of different ways of controlling the radio, but already there were Arduino shields that could implement most of those controls. We just had to do the radio portion. That was the real contribution that we would make, which means that the shield that we're making actually is fairly simple. It has this radio transceiver on it, and the radio transceiver is off the shelf. We know it works. We know it works pretty well because it's used in quite a number of handy talkies. And then we build everything around it that we're going to need. So we have the audio for it. We have the control signals, which originally the plan was to use I2C. And then we power it. We run that through a PA, through some filters, and then let people connect that to whatever they want, whether that's just an antenna or another PA with more gain. So this was really the high-level block diagram of what we were going to build. And what we did was we separated each of these different pieces of functionality into a separate board. We tested each board individually. So we had one board that just broke out the transceiver that we were using, the AU1846, and connected that to the Arduino and let us test the communications with it. and just connected that to a separate board that tested the PA, separate filter boards, so that it would make it really easy for us to iterate quickly and test a lot of different things. We got a lot of help from the community, and this was something that actually surprised me as I was getting into ham radio, is just how open and welcoming everybody was, and how much, when I said, oh, I've never done this part of radio before, like, people just introduced me to a lot of different people. People volunteered to let us use their test equipment. It was really great to get that much help from the ham radio community. And we ended up with a set of boards here. Casey showed you this board. This is one of the first prototypes that we have. And you can see this is the transceiver. We have an audio jack on there. We have some power on here. But most of the RF circuitry, especially the PAs and the filters, we implemented as separate boards for our first prototypes. And we tested all of this out. We got all of this working. And then we went forward to the Kickstarter. And I'll let Casey tell you a little more about that.
I would imagine some people are familiar with Kickstarter, but I've noticed it's relatively new to amateur radio. I know there's been a couple of amateur radio Kickstarters out there, but for the most part, it's for novelty tech items and potato salad and all kinds of goofy stuff. But people have raised a lot of money for a lot of different projects with Kickstarter, and some actually have raised millions of dollars. We didn't quite raise that much, but we raised actually a pretty surprising amount of money, and it kind of goes to show that this is a great tool for amateur radio operators, because we're always building something. We've got lots of great ideas, but we need money, of course, to actually put everything together and make our ideas come to reality. So really, the best way to get people excited is just explain why it's exciting. And we all know amateur radio is exciting, but we need to convey that in a video. The other neat thing about Kickstarter is there's a really big community of supporters looking to back different technology projects. So once you kind of get somebody's attention, it spreads like wildfire, and they start posting on Twitter and so forth. And we actually got picked up. It was really funny. I think we went live very early Tuesday morning. I finally finished the video, and I posted it to Kickstarter, and I was about ready to go to bed. And apparently somebody saw that it popped up on Kickstarter as a new project, and it got retweeted, and then suddenly we're in a bunch of different news cycles over in Europe before I even woke up the next day.
And I just want to say a couple words about the process of putting together a Kickstarter. We had working hardware. We knew that we could make this thing happen, but the big question is, how do we actually put together a Kickstarter that's going to A, convince other people, and B, make it easy for other people to get involved. Like I said, we had a lot of help from the community at the beginning, and we wanted to keep that help going. We wanted to make sure that we were engaging with them and really showing people what it is that we could do and why this was exciting. So at first, we spent a lot of time going back and forth about, okay, we really want to be successful with this Kickstarter. Maybe we should ask for a low amount of money. Or maybe we need to have this super fancy video that has all these special effects, or shows us doing really cool things. But actually, what we settled on was one of the most important things for making a successful Kickstarter here is just showing people, this is what we're doing, this is why we think it's exciting. And so we just basically stood in my apartment with a camera facing at us and talked about why we were excited about it, and got enough from that we could then put together most of our video. And then we filmed some of the projects that we had already wanted to make for it, and kind of went over some of the examples that we had. And like I said, and like Casey mentioned, we originally thought about asking for actually less than we thought we would need, in part because there's this kind of general wisdom that on Kickstarter, if you just meet your goal, that's a failure. You have to blow it away. You have to do all of raise millions of dollars. And so there's some amount of strategy that people talk about with Kickstarter about setting your goal lower than what you wanted. And what we decided was we just want to be really honest. We actually, this is kind of a difficult thing that we're doing for the first time. We're going to ask for as much money as we think it takes. And we did kind of explain where we expected that money to go. And yeah, the response was really great. We ended up getting much more than our goal.
And we took a look at different costs factors of actually taking this product to market. And we asked actually for 25,000, and we actually cut that in about a day. But you need to set your expectations. Something realistic. We put in a lot of hours here, and I would imagine that some people maybe even sell themselves short, maybe even not ask for the amount of money they need to actually produce the product, and you don't want to be spending money to be shipping your Kickstarter.
So one aspect of the Kickstarter that I think kind of had its pluses and minuses was we had a lot of stretch goals. So we met our goal of raising $25,000 to actually start production of this pretty quickly, and said, okay, well, if we raise even more, then we'll make all of these instructional videos. And if we raise even more than that, we'll give people really nice antennas. And if we raise even more than that, well, we'll completely redesign the PA section. And we ended up raising enough that we hit that point where we said, okay, we're going to redesign the PAs. We're going to give people higher output power. And, well, then we had to turn around and actually do that. And that's where we started to have some problems. We designed the PA. We've got a little bit over half watt output power now for all 3 bands that we're transmitting on. But that did cause some last-minute headaches that weren't expected, which definitely pushed out the timeline. We were originally planning to ship in October, and I've definitely talked to some of you today. We're like, where's my HamShield? Well, this is why. The stretch goals that we set, I'm really happy that we set them, but they definitely impacted the overall plan. And so this is one of the lessons that we learned about Kickstarter, is when you're setting stretch goals, make sure that you're taking those stretch goals into account when you're communicating your schedule and kind of what your plan is to people.
Yeah, we actually added, well, we figured out how long it would take us, what we thought, to make HamShield. And then we added a couple months, and apparently that wasn't enough. And it seems like things always come up. So actually, I think my lesson learned is don't be afraid to maybe add a few more months or just kind of overshoot what you think from the start of how long it's going to take you. The other thing that's interesting about Kickstarter is, unlike any other technology project, and I'm in the technology industry, when you make a product, you don't have a bunch of backers, basically waiting, okay, when is it going to ship? When is it going to ship? There's obviously all kinds of delays that occur, in hardware, since you have software and hardware to worry about, and it kind of goes unnoticed. But it's sort of like a public display of a technology project in general, and I think that's why a lot of hardware Kickstarters are delayed. And I really was trying not to be one of those projects, but unfortunately we ran into a few issues here and there, and it is what it is. But I think the thing that at least Morgan and I tried to do is at least be extremely transparent in how things were going. That's really important to kind of build trust, because there's been some Kickstarters, and I've actually backed a few of these, where they kind of disappear for a while, or very vague updates, and that makes me feel uneasy. So we've tried our best to kind of communicate what's going on. Thank you. We did something. We tried to do something a little different, and we did think.
Great job.
Oh, thank you, thank you.
I had no anxiety because of the communication.
Oh, thank you, thank you. Glad to hear that. So, and another thing that wasn't too transparent is, maybe funding or schematics or like very fine details as to what we're doing. Oh, go ahead.
Kind of on that note of transparency, one of the things that we wanted to take a moment to do right now is tell you about what exactly the issues were that pushed out our timeline. So we redesigned the PA, and the PA that we redesigned actually worked as a separate board. And then when we integrated that onto the HamShield to make a single board, we got our first prototypes in, and sometimes they worked and sometimes they didn't. It was very sporadic, which made it very difficult to figure out what was going on. And that's not something that we can ship to you. So if we say, oh, this works 70% of the time, that's not good enough for you. So what we did was we spent quite a bit of time just debugging this, looking into the hardware, seeing, okay, is it a problem that we had with the design of the power amplifiers? Is it a problem with how the power amplifier is integrated in with the transceiver? Is the matching not right? And we really went through every single thing that could possibly be, kind of several times. and had a lot of trouble figuring out what the issues were, which is kind of, that's one of the things about radio projects, is that they can be pretty difficult to debug. What we ended up realizing is that there were two different issues. These two issues both had similar symptoms, which is one of the reasons it was so difficult to debug. In general, some of the boards would just stop communicating over I2C, often during transmit, but sometimes they wouldn't even communicate over I2C during receive. Now, one of the issues that we found was a ground loop. For those of you who don't know, a ground loop is basically just if you have a big circle of wire in your ground plane. Now, you'll notice the Arduino here is basically has a full ground plane across the entire thing. The HamShield has a full ground plane across the entire thing, and there's pins on both sides, so you slot them together, and because there's ground pins on both sides, that makes a big circle that can then act basically like an antenna. So if you're not careful, this ground loop can pick up a lot of the RF energy that you are that's in your radio that you're transmitting, and this causes a lot of problems. Now, luckily, once we identified this, it's easy to fix. Just don't connect to your ground pins on one side of the Arduino, and that solves your ground loop issue. The other problem that we found was actually quite a bit more tricky because the shield that we designed, the updated shield with the higher power amplifiers, was a 4-layer board, but our original board was only 2 layers. Now, we didn't expect this to have any issues, but because it's a 4-layer board, the distance between the ground plane on the board and our I2C traces was actually quite a bit less than what it had originally been, increasing the capacitance on those traces. And the RF transceiver that we chose had a bus capacitance limit of 40 picofarads, which is actually not a lot. By contrast, the Arduino has a limit of 400. So this transceiver, we were kind of like pushing the bounds of what capacitance it could actually communicate into. And the problem with this is that that's actually a pretty difficult problem to fix. If our bus capacitance is, say, 20 picofarads due to the ground plane and the pins that we have on our board, we don't necessarily know what somebody is going to plug the HamShield into. Maybe they plug it into an Arduino Duomelanova, or an Arduino Uno, or Arduino Mega, all of which have different geometry, different design, different capacitance in fact. So rather than trying to fix this issue, we actually switched the communication interface that we were using to control the transceiver chip. And we originally went with I2C because the alternative interface for this transceiver was non-standard, kind of this weird hybrid of SPI and I2C. So the new HamShield, it's a lot more reliable, it works a lot better, but it uses an extra pin for communication, and also requires bit banging. So it's a little bit less efficient, but still can totally accomplish everything that we had intended it to do. Once we had identified those two issues and figured out how we were going to fix them, we had a test board made, and it worked beautifully, no problems. So now we were ready to actually go into manufacturing. And manufacturing hardware projects, especially Kickstarter projects, is a little bit of a minefield. There's a lot of different directions you can go, some of which are very, very complicated but very cheap, some of which are very expensive but also kind of take a lot of the headaches away from you. For a little while we were thinking, well, maybe we'll actually have these things manufactured in China where it's really cheap. But we had a couple of reasons that we didn't want to do that. One, we really liked the idea of having the HamShield be American-made. But also, to some extent, for small projects, especially for Kickstarter projects, having things manufactured abroad can be more expensive than having them manufactured locally. So it's not just we want it to be American-made, but it actually did make sense for us to have it made locally. Our manufacturer is in Tequila. We're using electronic service providers. And we had our PCBs manufactured. Our PCBs are actually at the manufacturer now. So we should be getting our first set of PCBs back in about a week and a half. So those of you who've been asking when you're going to get them, it's very, very soon. But just to say a couple more words about why we do really like working with local companies. When we had issues crop up, like when we realized that we had those communication errors with our first prototypes, it was really easy to work with the manufacturer because we already knew them. I could just drive down and talk to them in person. There was no language barrier. It was very, very easy to work with them. They made things very simple. And there was definitely a lot of back and forth that I think wouldn't have been possible if we had made some other decisions there. So I do definitely think that local manufacturing is something that for radio projects is totally doable.
Yeah, this company, they do surface mounting and pretty much all the new fancy mounting technologies. So very easy to work with, and what's really neat is when our first boards, the final run, come off the line, we'll be able to actually pull that off and do some quick testing, and then kind of authorize the rest of the run to complete. And you could not do that in China. I guess if you were on the ground there, but this manufacturer's been easy to work with, and actually the price isn't bad either. So. It's actually very competitive. All right, so.
Once we actually have these HamShields, once we're shipping them, they really don't do anybody any good if people can't use them. And this is one place that I think a lot of Kickstarters actually fall down, is user support. Like if I get my whiz-bang new product and I don't know how to use it, there's no instructions. Maybe I kickstarted a project a couple months ago and then got my board, and there was no instructions, not even a link to a website where I can find more information. So we really wanted to avoid that with the HamShield. Just like through the whole Kickstarter process, we're trying to provide as much information as we can to everybody about how to use the HamShield, provide a lot of examples, different Arduino libraries, basically make it possible for people to get started in like 10 minutes from when they get their HamShield to assembling it to being ready to actually put some code on it and make a contact. So to that end, we've actually put quite a bit of effort into making some videos, writing up some guides, and all of this is going to be going on our website as soon as we start shipping so that we can really make things as easy as possible for people so that they can take the HamShield and then make the next thing with that.
Yeah, one thing I guess we forgot to mention, although some people know already, is that HamShield is open source hardware and software, meaning we give away all the designs, Gerbers, schematics, all the source code, everything. And so, you'd have to read the GPL license, but basically it allows pretty much anybody to take that design and change it around and maybe even make their own HamShield if they want to. You could even, make it yourself. You could get the PCBs manufactured and, put one together yourself, buy the components, or, maybe you wanted some digital capability and you wanted to reuse their amplifier stage we designed. So you can definitely take things to the next level, even before we kind of move on to the next HamShield.
All right, so that's a quick discussion of the HamShield, the process of kickstarting it, and the process of designing and dealing with design issues that have cropped up. You can see here kind of the specs of the HamShield, and what we'd really like to do is give you a lot of time right now to ask whatever questions you have. I know we have some backers here. Any questions you might have about the HamShield, the design process, the Kickstarter, anything like that.
Can you make sure that they have the mic?
Okay.
Oh yeah, sure. Yeah, I'll just pass around the mic here.
The possibility of the Chinese taking your design, taking your Gerbers, and then manufacturing it using inferior components or leaving things out, doesn't that concern you? Because those boards would, quote, be called by the same name, be sold for half the price, and probably wouldn't work very well, and it would end up giving you a bad name.
And technically the license says that you're not allowed to benefit commercially, I believe, in some aspects. But
well, I think another aspect of that is that because these are open source designs, we kind of expect that to happen over the next year or so, for there to be clones of this. And to some extent, we're kind of hoping that happens because we want to really push things forward and make radio easier and more accessible to people.
Yeah, there's a couple of already, you know, I wouldn't recommend buying any of them, but there's some RF boards I saw on Deal Extreme for $10 that apparently somebody put them on a spectrum analyzer and it's just like all over the map. But the hope is that, you know, the economies of scale, maybe somebody can leverage it. I hope that they do something responsible with the HamShield design and lower the cost. I think that's a great idea.
So I may be the only person in here that doesn't know anything about Kickstarter, but what's the expectation of, for lack of a better word, the investors in this? I mean, it's not like angel funding a startup, right? I mean, you pay some money. I mean, what's the expectation for the so-called investor at the end?
So that's an interesting point, and I guess we have a little bit of time to talk about that. But the way Kickstarter works is somebody has an idea, they have a pitch video that you can watch in the description, and then there's reward levels on the right. And it could be something simple like a recognition of your name in something, or maybe a postcard. We did a QSL card, it's kind of cool. And then obviously we have, you know, different HamShield reward levels. And what happens is you give your money to Kickstarter, which in turn takes a small little cut and gives it to the person or business, and there's some gotchas there as well, to go make this thing. Now, I know that Washington State has kind of gone after a few Kickstarters where somebody didn't do anything, they kind of ran off with the money, and that does happen. I mean, you can read all about it. I mean, it's a small percentage of projects, but that can happen, and that's actually completely irresponsible. But when you fund something at Kickstarter, you get this. The only thing you don't get a share of the company, you don't get any sort of investment at all. The only thing you get is sort of a reward, which is the product that they intend to make. It could be maybe not exactly what it was described as, and there might have been some technicalities, but as long as they make an effort, you know, you'll get something. And I've done, I don't know, maybe about 20 Kickstarters, and for the most part people do hit the mark, and then others are really late and might sort of hit the mark, you know, it just depends. But there's a lot of risk involved. It's not, I think people mistake that Kickstarter as a store. It's not really a store. It's sort of a way to help a small business build something cool. And a lot of people have done some very responsible, you know, things with it, but it's sort of a grab bag, if you will.
I wonder if you could spend a few minutes talking about the certification process for spectral purity and other things, and how a Kickstarter-style RF project would approach such a thing.
Well, that's a really good point. We've been able to leverage a lot of different tools, and as an amateur radio kit, you know, we can kind of, you know, as long as we're within the spectral, you know, requirements the FCC has, we do well. But you know, we're okay. We don't need to get. We can't really get a board certified anyway. The FCC doesn't certify, you know, modules like that. But we used a variety of test equipment, spectrum analyzers, and we've looked at the spectral purity of the radio, and it's within compliance. And we actually put a great deal of filtering, which I think it might knock the power down just slightly, but for the most part, it works really well, and it keeps us within, you know, the emission requirements. But oh, go ahead.
I think that that's also one of the places that we have actually found the ham radio community to be most helpful, is people pointing out, okay, this is the exact specification you have to hit for your kit. Here's some test equipment that you can just bring in your device and you can use this. So people have been very, very generous with loaning us test equipment, giving us advice, and making sure that we're actually going to be complying by all of the regulations that we need to as a ham radio kit.
Hi, I'm not a FM ham, but I've got a question about it appears you're using the same chip as the Baofeng radio. Can you tell us what the aspects of your kit are as compared to these little handheld radios that sell for $100 or
And the Baofengs, apparently the price has dropped even more on the Baofeng, and I had one delivered for Amazon Prime Now, where literally a guy shows up 10 minutes later with the radio. I think it was like $25 or something like that. So the radios are dropping down in price, and we can't compete with that, obviously. We don't have to, we're not, you know, we're not a business in China and so forth. But I think where we actually shine is a Baofeng is a fully complete radio. You know, there's no serial port. You can't access the features of the radio. Where we come into play is our radio is fully configurable, programmable. We basically give you the full audio input and output. We can actually turn off, preemphasis, de-emphasis, and essentially give you the discriminator output. But you can take this audio and do packet radio. You can do voice. You can do SSTV. You can create new modes, maybe a new digital mode. So this allows the user to build whatever they want. They can change the frequency. You could make it into a scanner. You could create some sort of packet radio voice hybrid where you get maybe voice trunking. So there's a lot of different things you can do. It is FM, so you can't do high-speed digital modes or anything too creative, but it gives the user a lot of configurability.
And one other thing to add to that is that with the HamShield, you can actually add on other boards very easily. So you're not just able to really innovate on the radio portion. You can add Bluetooth, or you can add GPS, you can add all of these things and automate it all. So you have this one package, you add a couple of other Arduino boards, which also have really well-documented libraries, and suddenly you have a totally new thing that can act completely on its own if you want it to, or that talks to your computer, or that talks to your cell phone. So really, that's the real contribution here, is that it makes it really easy to integrate with anything else.
Oh, okay. All right.
If I had a minor criticism of your effort to date, that would be that it wasn't really easy to understand exactly what the capabilities were going to be, and you explained it perfectly, that it's an FM radio and all the other operational aspects, frequency, et cetera, are under software control. But the hope was going to be that you could, say, use codec 2 or some of the other, modulation methods, or high-speed packet. And I'd encourage you to do that for a follow-on project.
Yeah, and it was interesting to communicate to a broad spectrum of audiences. Obviously there's people with different technical capabilities, and so when we made the video and the material, we wanted to hit the broadest market there. But yeah, it is just an FM. Although the neat thing is, since we went through all this trouble of building this wonderful amplifier, this chip up here on the left, there's some great digital chips out there. Silicon Labs has a few of them. There's a couple others out there. But you could easily do a follow-up project, whether it be us or the community. It is open source. So.
How does your product compare to, or your project compare to the Radio Shield RS-UV3 from Hobby PCB?
That's a good point. It was actually interesting because we've been working on this one a couple of years before the Kickstarter started, and it just so happened that Hobby PCB also had another something very similar with very similar specifications. And I think it was just happenstance that this radio IC hit the market and people started messing with it, and so Hobby PCB made it's sort of a kitchen sink. It's got everything imaginable. It's got a microcontroller on board. It's got Arduino Shield compatibility. I believe it's got a serial port and all kinds of things. Our HamShield is a little bit more simple, and I don't know if they give you direct access. I don't think they give you direct access to the Octus chip itself, but it does have sort of a serial layer to it. I would imagine they're similar in some aspects. I believe our HamShield's smaller, so it might work in different applications. We have some people interested in doing high altitude ballooning and so forth, where every ounce counts. But yeah, they're very similar products. And I believe we have a bit more power output, but they've been, I believe they're working on a new amplifier stage, and I mean, that's a great company. I think it's just, they're kind of catering towards everything, and we're catering towards just Arduino and you know, customizing and configurability. So, oh, okay. Any other questions? Oh.
So you guys actually got a totally custom antenna made from, was it Smiley?
Well, I wouldn't. I think it's just undiscovered. I don't know about custom, but we did have them make a whole bunch of these for us, so it might as well have been a custom order. We kind of overwhelmed them. I told them, yeah, I need about 1,000 of these in a month or two, and they kind of like fell over because apparently they only keep about maybe 100 in stock, and then they slowly dwindle down. This is the Smiley antenna, and they went out and bought all the parts for it and everything, and put them together. And you can, it's a metal antenna, which I'm not a big fan of metal antennas, but it does have this. Hold on. It's got like a flex base at the bottom, so it kind of makes up for it, so you don't have to worry about, you know, breaking it. And you can match it across the 3 bands, you know, depending on what mode you're in. And I've noticed too, I put this under what was it, network analyzer, and you know, you could even finely tune it across the band if you wanted to, but maybe mark it off the Sharpie. But but generally, just kind of go by, you know, dropping down the, you know, the different segments. There was a question back here.
Yeah, was this a full-time job for you, or was it more of a second job, evenings and weekends?
Well, that's a good point. I've got a full-time job currently, so it's a bit challenging. And Morgan, you know, has you know, work as well. So this was sort of a. It's kind of funny how this worked out. So we put this out there in the world. We're like, well, I want to validate to see if the HamShield should exist or not. You know, let's just put it on Kickstarter, see if people like it. And we didn't know what was going to happen. And we didn't know that we were going to have such an amazing response. Like we expected, oh, well, it'd be awesome if we hit our goal of 25,000. Well, we hit 117,778 backers and about, well, after pre-orders, over 1,000 of these HamShields, which is just remarkable. So this kind of was supposed to be a hobby, kind of like a fun project, and it turned into, well, to Morgan especially, since he's the electronics genius, into more of a full-time job. But he has, I mean, yeah, I work at AT&T. I've got, you know, I'm an architect there. I've got a full-time job, and Morgan's, you know, got to pay the bills as well. So it's been interesting. And the way we formed this Kickstarter is and if you ever do a Kickstarter, please keep this in mind. But we actually formed an LLC rather than just like a sole proprietorship. Some people just put their social security number in and they're like, you know, send me the money. But from a tax standpoint, you have to be very careful. So we actually formed a company, an LLC. We got a you know, a company bank account, and we kind of did everything the right way. It's the right way to take money from Kickstarter, and it's sort of a side business, I guess you could say. The idea is we're going to you know, ship all our Kickstarter items. We have a store up now to sell, you know, these HamShields as well to people that weren't on the Kickstarter, and then we're going to try to work out a distribution deal because you know, I don't know if we can you'd be packing boxes forever. That should kind of bring the load off of us so we can work on, you know, designing something new.
No, actually,
oh,
I need the microphone.
Oh, you need the microphone. Okay.
I'm going to do something really horrible. So we're live streaming, and I have 2 questions from the people watching. And of course, I've taken Morgan's or Casey's mic voice. So first question is, you tried to partner with someone else on Kickstarter for GPS tracking. Were there any other vendors you tried to partner with or test with? And that was from Greg Evans. And Tom Hayward asked, and I'm not sure if I got this right, not a fan of metal antennas, what conductors does he prefer? I didn't know if that was an inside joke or not, so, but I had to ask it. Are sub-audible tones and DTMF tones part of the Arduino HamShield combo, or do those still need to be added / developed?
Okay.
And I'll bring this back to you. So
All
you
right.
got 3 questions queued up.
Okay, I have a terrible memory, but I'll try to remember all these here.
DTMF tones, metal antennas, and partner.
So there was a Kickstarter, I believe what he's talking about is Traxor. And that was an idea of creating a little ballooning transmitter. And I believe that Kickstarter was not successfully funded, which is really unfortunate because it was a really cool project. But I believe the guy actually went off and built a website and is taking pre-orders. And I believe that's what he's talking about. I'm trying to think of other folks out there. There's been a few other folks. There's somebody who was trying to do SDR on the Raspberry Pi, and I don't think we specifically partnered with him, but we were trying to help promote different amateur radio projects out there. There's no compensation or anything like that. I just was trying to help some of these projects come to light. And the comment about metal antennas, that's actually really funny. I know literally there's a metal conductor inside, but what I was referring to is just the actual metal, the rigid, there we go, that's the word we want. I'm not a fan of rigid antennas. I've broken enough of these. And then there was, but there was one last thing about DTMF. So there's 2 ways you can do DTMF. You can generate DTMF on the Arduino, and the other way you can generate it is using the Octus chip itself. It actually has a DTMF generator. In fact, it has a fully configurable tone encoder and decoder. And although I'm not going to do it, but supposedly you might be able to use that to even do a digital node perhaps, but I'm going to leave that up to somebody else to figure out. But the Octus does have a lot of different tone capabilities.
So I have one last question. Is there going to be a live demo today?
Yeah, we're looking to do a live demo today.
Okay. I didn't ask if it would work, I just asked if you were going to do a demo.
Yeah, we're going to do a live demo today. Great, so we have
Any other questions? Okay.
Oh yeah, go ahead.
Oh, well, hold on a minute.
Oh wait, yeah, I should probably
Next speaks unless properly authorized.
Simon says.
Okay, so having learned after you've shipped it, after they're for sale to the, after you've satisfied all the Kickstarters, so having learned all that you did, what's next? If you don't want to, if there's no spoilers.
Well, I will say that I'm just going to take my HamShield and use it for all the things that I wanted to use it for originally. I have a couple of robotics projects that I'm thinking about putting the radio in and just like, we built this thing, now let's use it. But also we do have some ideas about ways that we can do other modes than FM. And so we're looking into ways that we can do that. But I don't want to say too much about that now.
One last thing. So this was an amateur radio project. Did it bring people out of the woodwork and start firing some imaginations from a non-ham audience?
Yeah, actually it did. I think what was really striking about this is, well, you have some hams out there that maybe have their license and are not active. And in fact, I got a lot of messages from people that were like, "Wow, I can use this. I can come up with something cool and actually use my license." And then we had some people that went out and got their licenses to use HamShield, which was really interesting. And in fact, I don't have any official metric, and maybe when we do the survey to collect addresses, maybe we'll ask a few key questions. But I believe we have a lot of relatively new people to amateur radio, which is kind of cool. So there was kind of a bit of a spark, a kind of a wake-up call. Because Arduino, it's always in the news. If something has an Arduino on it, obviously it makes a lot of headlines for some reason. So Arduino attracts a lot of attention, and people are really excited about actually having a radio that can actually do something meaningful, as opposed to Bluetooth or something that goes maybe 30 meters, if that.
Was there any other questions?
I guess we got 10 more minutes before lunch, so.
So what sort of successful contacts have you had on the air using your HamShield? Have you tied into repeaters? Have you done, just communication with people simplex? What have you used it for?
We've used it for simplex. We've done maybe a couple repeater contacts just to test. One thing that I like doing is packet radio. So I was using APRS, and we hit. I can hit Mount Baldy from my house in Federal Way, which I believe is about, it's about 35 miles away. And that was without the best amplifier stage. And then I also, in Portland, we did a few demos, and we were able to hit some APRS gateway that was like in Washington, on a mountain peak on the other side of the Columbia. So we've been able to do some fun stuff with it. One thing that I haven't been able to do is actually sit down and enjoy it because I'm too busy, testing it and making sure that everything's good. So we've done, a few, token contacts and done some stuff with APRS, but I'm looking forward to actually being able to, relax and use HamShield, after we ship.
Quick question. I'm a backer, but I'm curious to find out, of the 700 that you've obligated to provide, how many are in this room?
That's a really good point. Could you raise your hand if you're a backer? Wow. That's really cool. Yeah, we've met a few backers here and there. I did go down to DEF CON, and maybe it might have a bad connotation or not, but there's a lot of hams that go there actually, and so I met a few backers there as well. And it's good to actually see people in person. It's amazing that how many people are out there.
Yeah, so you mentioned earlier the possibility of using Bluetooth or something to connect it to a smartphone or an Android device. So have you actually done that? Have you tried connecting a phone to this board and using it?
No, we haven't. Well, I don't know if Morgan has, but...
I have the beginnings of a project going, but I haven't gotten enough time to work on it. My current next step is to connect the HamShield to an Intel Edison, which has Bluetooth Low Energy, and then I want to use that to actually be able to change channels and control output power settings and all of that kind of stuff from my phone, while it's still using just a headset for voice. So that's the next step, but I am planning to go further from there. So.
And there's a lot of good opportunity on low energy. A packet radio is relatively low bandwidth, and low energy is perfect for command and control of the radio. Okay, go ahead.
So does the HamShield actually have a microphone amp and audio amp, or do you pretty much have to do that some other way?
Well, the HamShield has two ways to communicate to its audio ports. One is just through the Arduino pins to the ADC and the PWM, which is filtered nicely. And then we also have a microphone jack. Well, it's actually a TRS jack. So it's similar to what you have on your iPhone or Android phone. It actually takes the exact same headset, so you can plug in and it's got an amplifier on it, so it's monetarily loud. And yeah.
And then for the speaker?
For the speaker, it goes. So if you have a pair of like stereo headphones with a microphone, go ahead.
So we have an amplifier on the audio out, but not on the audio in.
So I have another question from the chat room. They wanted to know how many are going to be available after you fulfill all your Kickstarter pledges, and are you going to do another run so there'll be additional ones later?
Yeah, so we're actually running about 1,500 boards right now, and we have 958 boards that go to backers. I think that's within a couple, correct, within one or two. And then we've got another maybe 100 in pre-orders. So we should have a sizable amount of HamShields available. I don't know how fast 100 or 500 will go approximately, but if we do run out, we will do another run, I guess.
So one other thing, there's at least 2 people in the chat room that are backers as well.
Oh, good, good. Well, nice to meet you online.
Any other questions?
D. Okay, got one.
You're going to run into your limit here.
5-question limit.
Okay, just curious, what were the, I'm just setting an arbitrary number, 3 coolest things you heard about that you hadn't imagined that people wanted to do?
I think for me, the coolest project that I've seen somebody want to do with the HamShield is use it on an autonomous boat that they're building, that they're going to have circumnavigate a lot of the San Juan Islands. And they're using the HamShield for, I believe, APRS and also as a other command and control channel.
We have several people that are interested in high altitude ballooning, which is really cool. And there's a big problem with getting very lightweight radios. They want to get under this certain, and I can't remember, but the FAA has a weight limit of where if you're under a certain limit, you don't need to do all very complicated things like a notice to airmen and all of that. So they're interested in very lightweight transmitters, and we're kind of within that range of lightweight transmitters. The other thing that sounded really interesting, and I don't know if it's going to pan out or not, but there were some folks that wanted to use HamShield in sort of an AMSAT satellite capability, which would be really cool. And it's kind of in the right power range, the right size, and so forth. So if that pans out, that'll be really cool to see one in space. Okay, I guess we're ready for lunch here, so I'll wrap up.
So, yeah, thanks for coming.
Yeah.
And you guys are going to be out, you have a demo table, so we've got a break coming up.
Okay, yeah, it'll take us a few minutes to set up, but thank you.
And hey, don't forget to subscribe, like, and share.